So I'm gonna do this one all in black and white, okay? And then this will be kind of, if I were to do this on paper, this is what it would probably look like if I just had a pencil or a pen. Because I do things in pen even though I probably shouldn't. So let's look at the second equation just because I think it's gonna be easier to do, okay? So y is less than -2. And again, just for the equation, you could say, I said do it in black, right? So y equals -2. We've seen this before where there's kind of that phantom 0x right there, if you wanted to show it, because that then tells us that the slope is the same as up 0 to the right 1. I mean, if you want to go that far, you could go 10 or 20, depending on where you start. But the y-intercept is important here as well, okay? So let's find our y-intercept. It's just a 0, 2 right there. Oh, sorry, it's kind of small. 0, 2, there we go. Oh, thank you. Reading's hard. So y-intercept 0, -2. So let's put that point on the graph. And again, hopefully this will be big enough that everyone can see it. There we go. Oh, come on. Technology, yes. I got it. There's my 0, -2. Now up 0 to the right 10. I kind of did that on purpose so I could just make a straight line without having to do too much work there. And of course, going to the left, there we go, boom. Okay, now this should be a dashed or dotted line because it's not equal to, right? So at this point, I'd say, look, I'm just going to take my eraser, and then I'm going to make these a little bit bigger, but just kind of erase little parts here and there. You can do it often, you can do it little. It's kind of like a Bob Ross moment right there. We're not trying to be, too precise on that, okay? So there we go. I got my dashed, or I guess it's a dashed line now. But I need to test one of the values, okay? And this is where the shading comes in, and try to be a little bit methodical about this. But I know that the line is not going through the origin at 0, 0, so I will be testing 0, 0. Okay, so in my original inequality, y is less than -2. I only have a y value to replace on that, which is nice. But I'm going to replace that y with 0. So this is saying 0 is less than -2. That's false. Since it is false, I need to shade the other side of the line. So, well, I'd say the top, right? So the test point was above, it's false. So I would need to shade below. Now, before you start just, jamming lines down here like this, I wouldn't do that, especially since I'm doing this with like pen or pencil, right? Here's what I would do. I would just kind of make some markings to know or to remember that I am going to be shading below this line. So, just some, happy trees. There you go. If my hair was out, I would feel a lot better about making that statement. But in any case, all right, so that's what I'm doing. So I've made a kind of a reference for me to know that not only do I have a dashed line, but it's shaded below. Okay, now I'm going to go to the other equation. -x plus 5y, and again, I'm only concerned about the equality portion of this. So -x plus 5y equals 7. Yeah, if I change this into slope-intercept form, it will give me the slope, which would be nice. But my y-intercept is going to be a piece of garbage. So I'm still going to do it, though, because I do want to see the slope. I think it's still going to save me some work. So I'd say go ahead and add your x's to both sides and zero that out. Drop your 5y's, which now equals x plus 7. Divide all the terms by 5. And again, I don't really care about the 7/5, which you could estimate. But I just get y equals 1/5 x plus 7/5. So I do have my slope now, okay? So up here, I'm going to say I know that my slope for the first equation is up 1 to the right 5. Whoops. Okay, but I still need some ordered pair to work with. And it looks like, remember I made that mistake on the last equation. I see that the x-intercept should work very nicely for this one. So let's see, we had -x plus 5y equals 7. And I'm going to replace the y with 0. Okay, so this is going to be the y value of my ordered pairs is going to be 0. 5 times 0 is 0, so I got negative x plus 0 equals 7. I'm going to make that a phantom 0 right now. And I got negative x equals 7. Just divide both sides, I'd say by negative 1. Some of you know to change the sign, that's fine too. X equals negative 7. So my corresponding x value here is negative 7. Negative 7, 0, I found it. It's right there. And for this line, we know the slope, because we found it already, is up 1 to the right 5. So up 1 to the right 5. Kind of got mixed up in that test point right there. Up 1 to the right 5. Up 1 to the right 5. I think that's all I can fit. And this one also will be a dashed line. So let's see. Okay, fair enough. So I don't actually see an intersection right now. That's okay. But let's go and make this a dashed line before I forget to do it. Again, whatever your method for making it dashed or dotted is really up to you. Okay. And so this line also does not go through the origin. So I get to test it. So I will test the origin here. Negative 0 plus 5 times 0 is greater than 7. That's my question mark. So yeah, this is all 0 on this side. So 0 is greater than 7. No, that's false. Okay, so that means that I would have to shade above that line. Oh, what the crap, man. Well, this one intersects off the graph. Let's see if we can make some sense out of what's going on here. Okay, so that line, let's pretend like I drew a nice line right there and another nice line right there. Okay, and they're both dashed. It indicates that the actual intersection between these two would be this section right here. And I know it's getting real sloppy. I'm sorry. I didn't expect it to intersect off the graph.